Add goal 2.2 notes to your table of contents in your notebook. Follow along while we go through the video here. Goal 2.2 reads, I can match a chemical formula with its correct molecule or structure. The point of this goal is to show you guys that atoms form compounds in lots and lots and lots of different ways. The possibilities of what a molecule or structure could look like are endless. So here are just a few examples of things you might see if you Googled the phrase molecule or compound. Elements combine to form compounds in different ways. So all of these that you see on your screen are considered compounds, and you can see that they range from small things like H2O, water, to larger things with more atoms inside the molecule. You even get some compounds that are large strands like DNA, and we have some that are more crystalline, like the salt crystal that you see there. So if we have non-metal elements, those combine and bond to form molecules, kind of like water, H2O, like what you see there. That we call a molecule. If we have a metal and a nonmetal, they usually form what's called a crystal lattice, or just a crystal for short, kind of like salt. So what you see there would be an example of what sodium chloride or table salt would look like as a structure. When I say metal and nonmetal, I am referring to what we learned last unit about the periodic table. Some elements are considered metals. Those are the ones that are to the left and below that stair-step line that are in blue here. Some are considered nonmetals. Those are the ones that are to the right and above that stair-step line that you see in that copper color there. And then there are a few elements that are an exception to this. We consider them to be metalloids. Those are those 7 elements in green. For the sake of this unit, we will just be dealing with metals and nonmetals, no metalloids. Every compound has a chemical formula that tells us the elements it is composed of and how many. This is going to be key to identifying a structure of a compound, is knowing how to decipher the chemical formula. So for instance, water, we know is H2O. There are two chemical symbols there. H is for hydrogen, O is for oxygen. And you'll notice that you see a subscript right below the letter H there, and that subscript is a 2. That lets us know that there are 2 atoms of hydrogen in a water molecule. If you don't see a subscript next to a chemical symbol in a formula, then that means that there is only one of that element. So for oxygen, we just have 1 in H2O. If the elements form a crystal, it's a little bit different here. Then the formula tells us not how many, but it tells us the ratio of the elements. So something like salt, which is sodium chloride, NaCl, I don't see any subscripts in that formula, NaCl. So that tells us that for every 1 sodium atom, there's going to be 1 chlorine atom in its structure. So what you see there is a salt crystal, and notice that for every 1 purple atom, you have 1 green atom. So the ratio is 1 to 1, hence the formula for salt being just NaCl with no subscripts. To match a formula with its correct structure, you need to match the ratio from the formula with the atoms in the structure. So for instance, take caffeine. The formula for caffeine is C8H10N4O2. If you had to pick a structure from the right to match with that formula, which one would you pick? If you guessed the third one down, you would be correct. The ratio of the atoms in the formula for caffeine match up with that particular structure. For potassium iodide, Ki, which one would you pick there? If you pick the middle one, you would be correct. And kind of like salt, NaCl, potassium iodide is another type of salt, Ki, and it tells us that the ratio of potassium to iodine is 1 to 1, and in that picture, you see that 1 to 1 ratio, which leaves us with glucose, C6H12O6. That's going to be that top picture there. And notice that there are 6 black atoms. Those would be the carbons. You see 12 white atoms. That's the hydrogens. And 6 red atoms. That would represent the oxygens. So in order to do this, to be able to match these, you need to look at the chemical formula, figure out the ratio of the elements, and match that up with the ratio that you see.